Hello everyone, I'm Kolanis from the Space Science Department of Institute of Space Technology, Pakistan. My project supervisors are Dr. Shaukat Numan Guderia from Tarleton State University, US, and Dr. Fazil Mahmood Khan from the Institute of Space Technology, Pakistan. We present the differential photometry of eclipsing binary system V798Her in the globular cluster NGC 6341. The cluster was observed for 26 nights during the months of April to August 2013, and the observations were obtained in Johnson's BVNR filters using 0.8-meter Tarleton telescope and a CCD photometer. The data was stored in the standard format, that is flexible image transport system, used by astronomers worldwide. The exposure time was 120 seconds for B filter, 60 seconds for B filter, and 40 seconds for R filter. The data was reduced using the GCX astronomical image processing software and the Python scripts. For differential photometry, we selected three comparison stars near the target system as shown in Figure 1. The basic data for the identification of V798Her and the comparison stars was obtained from astronomical database SIMBAT, which includes the identification ID in GSC and Tycho catalogs and their fluxes in different filters and their coordinates. All are listed in Table 1. Now Figure 2 represents the constant nature of the comparison star by taking the difference in magnitudes of C1 minus C2 and C1 minus C3 in filters B, V, and R respectively. Since we need to determine the variability of the target system, constant stars will go through the same changes due to atmospheric variation. By finding the difference in magnitude of comparison stars, atmospheric effects will not be a significant contribution to the variability of the target system. Now for period determination, we used P_search 15F software with Fourier transform technique. However, the observed period is slightly different from the published one. Epoch of minima. The epoch of minima was obtained in heliocentric Julian date using the software Minima 25C with the Kiwi and von Boden technique. The equation 1 represents the observed light elements on the target system V798Her. Now to track the changes of observed minus calculated values, we plotted a graph of observed minus calculated values using least square calculations. It gives us a straight line which tells us that we have correctly determined the period and epoch using first order correction. If that is not the case, then we go for higher order corrections. After we find the correct period, then we determine if there is a period change from the previously published period. However, in our case, new period is different from the published one, but the change is very small to do any meaningful period analysis. Further, the fact that second order correction was not required shows that further period analysis is not required. Now for the light curve modeling, we used Wilson-Devaney mathematical model. First, we determined the global mass ratio by obtaining convergent solution for a series of fixed values of the mass ratio. For V798Her, the mass ratio with unique solution is 0.8. However, all possible solutions are represented in Figure 4. The photometric parameters obtained after differential modeling of V798Her are listed in Table 2 and for no spot and spot solutions. Here the mass ratio is 0.88 for no spot and 0.89 in spot solution. The inclination is 66.31 in no spot and 66.13 in spot solution. Since I used mode 3 for contact binary system in the mathematical model, with one of its constraints that potential of one star is equal to the potential of the second star. So it is 3.5539 in no spot solution and 3.5733 in spot solution. The temperature of the primary component um, is fixed for in differential while differential correction for no spot and spot solutions, that is 4920 Kelvin, and the temperature of the secondary component is 4832 Kelvin in no spot solution and 4697 for spot solution. The bolometric albedos for reflection, heating, and re-radiation on stars 1 and 2 respectively is assumed to be zero point 0.5 for convective envelopes. The bolometric gravity brightening of star 1 is 0.1933 for no spot solution and 0.2438 for spot solution. Similarly, for star 2, it is 0.4454 for no spot solution and 0.4364 for spot solution. The mean residual for no spot solution is 0.00164 and for spot solution is 0.00098. The observed light curves after the determination of light elements show that V798Her is the W Ursa Majoris contact binary system. Figure 5 shows the final plots of observed and computed light curves of V798Her in filters B, V, and R respectively with superimposed spot and no spot solutions. The final configuration of V798Her at phase 0, 0.25, zero point 0.5, and 1 is shown in figure 6. Now, according to the Harvard classification scheme based on temperatures, both stars belong to spectral type K, where neutral metal lines are most prominent. The fill-out factor calculated using Richinski equation indicates that the stars are in contact with the inner critical surfaces. According to the period spectral type diagram for contact band V798Her appears to be a zero-age contact system with case A-type mass transfer, that is core hydrogen burning phase. Now, I would like to acknowledge Dr. Shaukat Noman Guderia for his supervision throughout the research and the Darlington State University for providing the data for the target system V798Her and allowing me the remote access to use their computer facilities. I would also like to acknowledge all softwares that have been used throughout this research. Thank you.